welcome to this video. In this question we are given a grid or a 2D array and it has ones and zeros inside of it. Okay, and we have to find the number of islands. So I'm going to explain you the question, what are the rules and what exactly it wants from us before I move on to the coding part. Okay, now look at this one. Okay, this and this. Okay, now these two ones are connected horizontally, these are vertically, these two ones are connected vertically, and these ones are connected horizontally. So an island is a group of one which can be connected horizontally or vertically. So by that logic, starting from here, so this one here, this and this, all of this is one big piece of one or an island, so we can count this as an island. Now there is another rule that we can assume that everything outside of this grid is 0. Okay, so 0 is water, 1 is island. So those are the rules. Okay, so if two ones exist diagonally, they cannot be considered as islands. Okay, consider this example here. This is a single unit, this is a single unit, and this is a single unit. That's why we have output as 3. There are 3 islands. Okay, now before moving on to the coding part, think about one thing. If there is at least a single one inside this grid, then that means that there is a single island. And if there is not even a single one, then that means the answer is 0. Okay, now let's move on to the coding part. So the first thing to do is create an integer called num island. Okay, now this will be our answer. Initially we will set it to 0. What we want to do is we want to traverse throughout this grid, okay, one by one through every element, and we will check if that is 1 or not. If that is 1, then we want to do something. If that is 0, then we will just move on, because if that is 0, then there is no possibility of an island for starting from that point. But if there is a 1, then that means an island can originate from there. But that is not all to it, so I'll start coding. So the next thing to do is for int I equals to 0, I less than grid dot size I plus plus. I hope you know how to iterate through a 2D array. And if for int j equals to 0, j is less than the first element inside the grid. Okay, so grid I dot size and j plus plus. Okay, not the first element, the ith element inside the grid, or the ith row. Okay, so rows and columns basically. So to find the current element, that will be grid I and j. Now what is the condition we are checking? If the current element is a single string 1. Now if that is 1, then that means an island can originate from here. But there is one more thing to consider. Okay, from here also island can generate, from here also island can generate, from here also it can generate. But this is all a single piece of island. Okay, these ones are not different islands unless they are diagonally connected. So we need to find a way to figure out if this one was visited before. Okay, so what I'll do is I'll traverse. If I'm over here, then I'll use a DFS or a depth first search, travel to every one possible from here. Okay, and then I'll mark that as visited. Okay, or I'll mark that as 0. Okay, so that will eliminate the possibility of a number being repeated. I hope that makes sense, but even if it doesn't, don't worry about it. So what I'll do is I'll create a DFS function. I'll implement it later. I'll just pass on I, j and grid. Okay, and then I'll just increase the value of number of islands. Okay, I hope that makes sense. Now the next thing to do is to implement DFS. Okay, and so to do that, let's create a void function. It's not returning anything. Okay, it will take x, these are positions x, y, and it will take another vector, or to be very precise, it will take the same vector grid and it will take it by reference so that we can make changes to it. Okay, now the first thing to check is that if x is less than 0, okay, these are fail conditions. If y is greater than if y is also less than 0, then okay, or let's say that x is greater than the size of the grid. Okay, it cannot be greater than the grid's size. or equal to, because indexing starts from 0. Now the same thing will be applied for y. Y greater than equals to the first item inside grid, the size of it, and then finally if the current element is 0, then we want to ignore it. Now in this situation, what I want to do is I'll simply return or exit the function. Okay, these are all the fail conditions, right? Now the next thing happens. Okay, so what I want to do is that if the current element, that is grid x and y, if that is equals to 1, then what I want to do is check, make sure that this particular value is turned to 0. Why? Because I've already visited it. Okay, so I don't want to do that again. I don't want to visit that again and then increase this num island for no reason whatsoever. Okay, now how to see, we're going to find the connected ones, okay, or the connected indexes. Now the connected indexes can be either horizontal or vertical. It says that only adjacent horizontal or vertically can be considered, diagonally cannot be considered. So there are 4 conditions to find the like the adjacent horizontal and vertical indexes. So in DFS, just pass x minus 1 y grid. I hope it makes sense. X minus 1 will give the previous x. Okay, same situation, x plus 1, and just pass y and pass grid. Now this is for the right. Okay, now DFS x is the same, but y plus 1. Y plus 1 means the next one. Now for previous y, it will be x, y minus 1, and then grid. So we will cover, so we are going to cover, suppose this is the place, this is the current index, so we will cover this, 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 and this. These are the items we want to check, and if they are 1, we will turn them to 0. Okay, because that's the only way we can find them, if they are connected. Okay, and this is the fail condition, that if suppose for x minus 1 x goes below 0, then I just want to end this. Okay, I hope that makes sense. Now the only thing left to do is to return the answer, which will be num island. And I think our work here is done. Now if I run this code, okay, okay, that's the, okay, so that's how you do it. Thank you so much for watching. I hope this was helpful.